My name's Andrew Couch. I'm a freelance developer consultant, and I'm an Access MVP. And I've been working for over 10 years with Access and SQL Server, building client-server solutions, which is what I'm going to talk to you about today. I do actually have a book out, and in the book we have sort of 5 chapters which are related to working with SQL Server. So that will hopefully provide some background information to what I'm going to talk about today. So I'm not going to talk about actually the process of conversion. I want to talk about, what actually happens once you've converted or you've linked an Access database to SQL Server. What sort of things do you need to know about? And there are going to be some of these techniques which are quite simple and straightforward, and some of the other techniques will be a little bit more complex and challenging. But what we're going to do is we're going to start off, I'm going to just discuss through with you a bit about connections, drivers, DSNs, and authentication. Then I'm going to talk about having some linked tables, some bound forms. I'm going to show you the SQL Server Profiler, which is a great tool, and I'll talk a bit about performance issues and how the profiler can help you resolve them. Then we'll move on and we'll look at 2 specific design techniques. The first technique is filtering with views, where I want to show you a really clever technique whereby you can take your Access screen parameters or query parameters, and we can kind of convert those to work on SQL Server with views. Another design technique I want to take you through is to talk to you about situations where you may need to use a local temporary table, and how you actually populate data in and out that table from SQL Server. And then we'll talk a bit about some SQL Server design stuff. I want to show you a little bit about temporary tables, and I'll also show you a more advanced cursor in SQL Server. And then I'm going to finish off chatting a bit about schemas and synonyms, and about how you sort of structure your application. So the first part we're going to talk about making connections and DSNs, drivers and authentication. So we'll talk about the authentication methods, the choice of your ODBC drivers, whether you want to use a file DSN or a machine DSN. And sort of over here we've got an Access application, and on the other side we've got a SQL Server database, and we're going to connect them. Now you can use MDBs or accdbs as your Access application, or you can also use ADPs. And today I'm not going to focus on the ADP side of things, although there's a lot of the techniques I'm going to talk about have applicability there. I'm going to focus on showing accdbs that are linked. I mean, one of the I prefer to use accdbs because it has the advantage over ADPs that it gives me the ability to make use of local Access objects, like some local tables and some local queries, and I can convert something piecewise, whereas an ADP is a bit of an all or nothing for me. So that's where we're going to go to in the first bit. So if I've got a shortcut here to this is to the ODBC data sources in the machine. That was taken from the control panel, and you get 3 types of DSNs or data source names. You get the user DSNs, which don't get used. There are system DSNs, and there are file DSNs. Now, the advantage of the system DSNs is that it's a name for something, and inside the links in Access, that's where the name occurs, and it's actually the DSN in the machine that holds the information on the server name and various other settings, the database name. So the advantage of system DSNs is that if you need to change something, such as to change the name of the server, you don't actually have any impact on the Access application, because all you have to do is change the details of the system DSN, which is set up on the machine. The disadvantage of system DSNs is you have to set them up in each machine. So if you had 20 or 30 users on each one of those users' machines, you would have to configure the system DSN. Good. Okay, the technique here's a typical situation in Access where basically we have a form, and the form has a control, and it opens a query and shows a result set, and the query is bound to the control in the form. Now, what I want to do is to discuss with you how you translate this through into a solution in SQL Server. And if we look here, the technique here is to create a table in SQL Server that can hold the user's choices. So what we have is we have a table here which has got, in this case it's got TXT country would be the choice that the user made through the form. And what we then do, it uses a special function called the sysuser sname function, which tags the user's Windows login or their SQL Server login and holds that value in the table. And then on top of that table, we construct a view, and the view is designed to only reflect back one record for each user. It's quite a clever type of view. And the view also has a with check option. This with check option means that the user can't attempt to insert data into the view that can't be seen back through it, so they can't meddle with anyone else's filtering record. Then the technique then is basically to create a view, but the view uses the value in this filtering table to filter down the results to show for the user. Then the bit down the bottom, this shows you how you can make it a bit more sophisticated, because one of the problems is that if there's no value, a null value for TXT country here, then this view is not going to show any data. However, by using a really cracking function in SQL Server called the coalesce function, the coalesce function here, what it does is if the user doesn't have a value in the filter, then when it's got a value in the data, it's going to compare country with, now TXT country is null, so it'll be with country, and so the record will be displayed. If the country value in a record is null, the coalesce picks this empty string, and in this case that's null, that's the TXT country is null, the country field is null, and we have an empty string, and it compares an empty string against an empty string. So this is more flexible. It also is more flexible in that if you want to filter by multiple parameters, because it's a cross join, you can simply tack on those additional parameters. So the next thing you have to be able to do is you have to be able to use this from the Access application. And what you do is you need to link to the filter, and you need to link to the view that you want to display. And actually, when you perform that link, and I can't actually show you this here, but when you perform a link to a view from Access to SQL Server, it's going to prompt you to ask you what are the unique fields. Now, this is very, very important, because if you don't specify any unique fields, the link to view is going to become read-only. And in order to make it updatable, you have to choose the right fields as the linking fields, as the unique fields. So if you are linking to a view of the customer table, then the customer ID is going to be the unique field. And similarly, you must do this when you link to the filter. And then what it's a matter of doing is when the user pushes a button, basically, this then goes through and it writes the user's choices into the filtering table. So the filtering table it only holds the value. Each user can only see their own value. Then what you need to do is you need to basically simply open the view, because the view, as we saw back here, the view is constructed so that it applies the filter. So that's a really useful technique for translating screen and other parameters in Access into a parameterized table in SQL Server. And this is just a schematic of how this whole process works. So the Access application, it links to the filter, and the user will write through that filter into the base table, into the filtering table. And then you link the view that you want to show the data back to the user, and that view incorporates the filter view to constrain the rows that the user gets to see. In general, Access can make these views updatable, which is quite clever. In fact, you can even have updatability flexibility when a view includes multiple base tables, although you have to make sure that each update only affects one of the multiple base tables. In general, I tend to avoid having to do that, but it is another feature that Access has. So that's really a way of improving performance, this need to move away from having your queries in Access and moving to using views in SQL Server and using filters to filter down the data. Another useful technique is, I tend to prefer most of the time to be working with linked views, and I use filtering to constrain down the views, but there are some situations where the performance on a linked view is insufficient, or you want to do a lot of processing after a user has made certain selections. In that case, it's a good technique to create a local temporary table. So you can see here I've got a local temporary table, and I've got a form below, and the form's got an unbound control at the top of it, and it's got a couple of buttons. And one of those buttons is going to populate that local temporary table, which is bound into the subform, and then the other button is going to write those changes back to SQL Server. And if I just look at the, just going to be a second while I just see the detail on this. So if you look at the actual code there, you'll see that the code basically executes a delete against the temporary table, and then what it does is it modifies a pass-through query, and it uses the pass-through query to be pointed to return the correct data, and then what it does, after it's written the pass-through query, it has to then execute another query to perform the population of the data, and then it requeries the subform control. Now, we really need to look at show you the next slide really to show you how the pass-through query is actually being constructed. Pass-through queries they are different from Access queries in that you can type into a pass-through query anything which is in SQL Server syntax. It passes through, if you like, the Access engine and goes straight to SQL Server. One of the advantages of that is in gains in performance. The disadvantage is that it's read-only. But in this situation here, where we are wanting to populate a local table with a copy of the data of SQL Server, the fact that it's read-only is not a problem. And in the lower part of the screen, you can see we can construct a standard Access append query, which appends the data from the pass-through query into the target local table. So you can actually mix. You have to be a little bit careful, but you can mix pass-through queries on top of standard Access queries. And then the next issue. So that's all you actually need in the first. In the previous example here, it really shows you all you actually need to put the data into the temporary table. But when I created the temporary table, if I just go back to that temporary table, I created a field called data changed, and I display that in the form. And then I can write some code in that form to automatically update that field whenever a user makes a change to a record. So I know the records that I need to write back to SQL Server. And then this is an example here of showing the write back that's required. And so, in order to make the write back here, again, I want to show you you could have used an append query for this, but again, imagine the processing in the write back is actually quite complicated. In which case, what you want to do is you construct a stored procedure in SQL Server that you'll be able to pass to it two parameters in this case. It's going to be the primary key, and it's going to be the value of the field that the user was able to change. And what this then basically does is the save button opens a record set over the temporary table, only picking out records where the data has been changed. It creates a temporary pass-through query, and it picks up the connection string from a physically connected linked table. And then it basically sits in a loop, building the SQL and the pass-through to match the particular record it's wanting to process, and it executes that against SQL Server. So that's using, in that example there, we're using pass-throughs to get data, and we're also actually using pass-throughs to write back our updates. And those pass-throughs for the updates are calling stored procedures in SQL Server. So, as I say, another alternative technique you've got is to use forms and to use local temporary tables. You lose concurrency when you do this because the data could potentially be changed by another user, which is one of the reasons why I prefer to actually use views for doing this. But in certain situations where you've got performance problems, having a local temporary table is a good technique to exploit. Okay, moving on. This example here I want to show you is an example. It illustrates two things you can do on SQL Server, which are very useful. The first thing that is equivalent, we talked about having access temporary tables. Well, in SQL Server, we can have a SQL Server temporary table. When you create a temporary table in SQL Server, you put hash in front of it. So any table with a single hash makes that a temporary table. So I could just have executed the... sorry, just let me go onto the slide for you here. This is the slide I want to be on. So you can see there that the line of code down here is how I actually put data into a temporary table. And I'm using this select into to create the table on the fly. And I could also have a piece of code here just to check to see if the temporary table already exists, then drop it. And it's a really flexible technique, this, because you can actually alter the structure of these temporary tables as you're going on. So in this case here, I wanted to alter the structure to add an additional column. And then by simply saying select, if I look at if I go into the next page here, and we look down at the bottom of the page, if you ignore everything that's up above at the moment, and if you simply look at the bottom of that page, you'll see that it's performing a select. Now that select will return the temporary table's data back to your Access application. And these temporary tables, they're all user specific. So you don't get conflicts. Multiple users can do this at the same time. So it's another very useful technique. The other half to this process that I'm showing you here, which is a bit more complicated, this uses a SQL Server cursor. And SQL Server cursors are like record sets. They are a little bit more difficult to use than a record set. And it starts, basically, you have to declare variables for all the field values you want to read from or update through the cursor. And this is where it's a bit more complicated in a VB record set. But the line below, where it says declare this cursor as a type cursor for, and then it says select the columns, and then you say from the table name, and because this cursor is actually going to be updatable, I have to say for update of the row I want to update. So that's a bit like your open record set command, a little bit more complex. Then you need to actually fetch data through into the variables from the cursor, and you put a loop on this while the fetch status is equal to 0, or you have more data to fetch, perform whatever you want to do inside the loop, and you do a fetch next, which fetches the next record into the cursor. And then the final steps are you close and you deallocate the cursor. So that's showing you two things. That's showing you the power of working with temporary tables, and it also shows you the power of cursors. Now, the last topic I want to talk to you about is working with schemas and synonyms. And this is a technique I tend to use a lot of the time. The advantage, one of the problems with it, well, with Access and indeed with SQL Server and all databases, is the fact that you can end up with a list of about 150 tables in your application, and then you've got all your views or remember I showed you the DBO schema, which is the default schema. You can also use create schema syntax to create your own schema, in this case a company schema. And then what we can do is we can create tables on that schema. When you create a table in SQL Server, the syntax you use is normally create table name. If you do create table DBO.table name, it puts on the DBO schema. If you say create table companies.table name, it puts it on the company schema. And so in this bit of code here, this actually will create a table in the fly on the company schema by using data from the customers table, which sits in the DBO schema. And you can see over here, if I executed this, it would result in the table shown on the right, which is called companies.company. Now, one of the problems with working with schemas is once you create schemas, if you want to perform a select, then you have to specify the full schema syntax. It turns out that any user on SQL Server has what's known as the default schema. And the default schema is DBO, and it's unlikely you would change that, so you're normally going to have to specify the schema name. However, SQL Server has another beautiful little feature, which is called Synonyms. And a synonym is just creating something which is a short name for something else, which is a more complex name. And so if I create a synonym called company for companies.company, in the line above where it says select star from companies.company, I could change that to simply say select star from company, because it will know by the synonym how to refer to the table in the schema. You can also transfer tables between schemas. The syntax shown below would move the company schema, would move the customer table onto the company schema, and the piece of syntax below that moves the customer table back onto the DBO schema, the base schema. So that's to show you can not only can you create things on schemas, you can also move existing objects in and out of the schemas. There's one other reason for using schemas, and that is that when combined with database roles, schemas offer a very simple way of managing security. So if we were to towards the bottom of the screen there, it says create role, and it creates a database role. And if you look next to it on the graphic, you can see there's a role there called read-only users. Now, I could then, my read-only users, I'd only want them to have select permissions on any table in the company schema. So by granting select on the schema to read-only users, that means that they can only read the data on that schema. So, as I say, for managing applications, schemas are brilliant, and you can combine them with database roles, and it makes managing your security very simple. Let me just flip back across again. Okay, so firstly, I'd like to apologize to everyone for the fact that I haven't been able to actually go through in most of this presentation and dynamically show things to you. But I hope with my commentary and subsequently going through the screens that you do feel it's been worthwhile and you've got something out of this. I think just to summarize where we've been to, connections, you have to think about some things here. Think about whether you want to use file DSNs or you want to use machine DSNs. Incidentally, when it comes to the drivers, one thing I didn't mention was if you choose a driver like an SQL native client driver, then one thing you have to remember is you have to go around the individual machines for your application, and you need to install that driver on the machines. It's not that difficult to do, and if you search online, you'll find Microsoft provide a package that you just simply run, and it will install the drivers for you. So as I said, you've got your file machine DSN to consider, you've got the driver choice to make, and then you've got to consider the aspect of authentication. How do you want to authenticate your users? And I kind of mentioned there that Windows authentication is really good and it's really useful, but there's a lot of developers who use SQL Server authentication because the advantage of SQL Server authentication is it means that you're not reliant on the company's infrastructure in order to get involved with things like how the various Windows groups are set up. I mean, authentication with Windows logins is very simple because you just create a Windows group and you put everyone who has to use your application into the Windows group. You register the Windows group in the SQL Server and everyone's authenticated. In some cases, other cases for using the SQL Server logins are if you've got maybe a demo application you want to send out to people and you want to make it nice and simple for them, having the embedded credentials and things there can be very useful. You can use SQL Server authentication and create one SQL Server account for every user who's going to use the application. That's a really good idea when you need to figure out who a specific user is, because the suser sname function will pick up that name. And indeed, if you're working with something like SQL Azure, which incidentally I haven't shown you here today, but SQL Azure allows you to link a desktop Access database directly into the cloud, then you're compelled at the moment to use SQL Server authentication. So I hope that's put some points forward there on the connections. Then we looked at linked tables, and I indicated to you that in general with linked tables, and bound forms, it's all about designing your forms so that you prompt users for choices, or you have boxes which have got filtering values in it, and you filter everything as you go along. You want to make sure you're always minimizing the data that's being communicated with SQL Server. That's the whole thing about client-server design. Minimize the data transfer and you'll maximize your performance. And I know not everyone got to see it, but the SQL Server Profiler is readily accessible from the SQL Server menus when you've in the performance grouping. When you install SQL Server, have a go with the SQL Server Profiler. It's a very simple thing to use, and it is very illuminating about the performance of your application, and that's the key tool that I use for solving performance problems. Then we looked at a couple of techniques, which was filtering with views, and I indicated to you how you could make an equivalent structure to the way we approach things, where we have screen parameters used for filtering. You can effectively push that into the SQL Server to make the filtering happen server-side. Again, making everything server-side improves performance. The other technique we looked at was working with local temporary tables, where you snapshot the data out the SQL Server, manipulate it, and then write it back. And in complex processing scenarios, that's a very useful thing to be able to do. And then the final sort of thing we looked at was I was talking to you about how SQL Server has got temporary tables as well, and how your equivalent to record sets are cursors. And then I finished off with my favorite topic, which is schemas and synonyms. It's a really good way. If you've got a big application, even in small applications I use it, but if you've got a bigger application, then schemas and synonyms are an ideal technology to use. Finally, if you want to download the samples that are used in this presentation, then I've got a link there for downloading the samples. I've also got a site. I sell a commercial upsizing product that's used by about 150 companies. I also have an awful lot of technical resource on that site as well. So lots of free articles, lots of things talking about designing Access applications when they're linked to SQL Server. So I think, yes, that probably brings me to a point where I've pretty much covered everything I want to do.
Great. Thank you very much, Andrew. And at this time, we have several questions that have come in. So if you're okay, I will take the first one and read it to you.
Okay.
Great. Question is from Brian. Brian asks, is SQL injection a concern?
Is SQL injection a concern? Well, I mean, SQL injection is normally associated with, I mean, you're really talking about a .NET application. for SQL injection, and yes, it's always of concern. You want to parameterize everything as heavily as possible. But the more you rely, building things using concatenation of values and controls, that's obviously in a .NET environment you would need to be very careful of that. In Access, you don't have to worry about that because you can't get really the SQL injection there. So yes, for .NET applications, you need to consider that.
Okay, and then we have another question from Vernon, and Vernon asks, how do you connect with SQL Server if it is remotely hosted over the Internet? And do you recommend using Access to construct an application that runs over the Internet?
Well, that's a very, very good question, Vernon. Basically, you can do it. You can connect a desktop Access application through to an ISP who's hosting SQL Server. Now, where I've come across people doing this, they have hosted with particular ISPs who have handled all the concerns with the firewall, and they've configured all the security to enable them to do this process. And I would say if you want to do it that way, there's an awful lot to be said for finding somebody who can support that for you, unless you have the skill set to handle all the security. My own personal experience has been fiddling around to make it work. It's not easy. I find it is really quite difficult to do because you get involved in all the aspects of the security in the server. The best solution is you put it in SQL Azure. Because SQL Azure, it takes minutes to configure it up. Okay, it's a chargeable service, so you have to obviously take that into account. But for simplicity, nothing beats SQL Azure. It's very easy to use. But it's a question that has come up quite a few times for me. And as I say, I would look towards trying to find somebody who could assist you by offering it as a service. I hope that answers the question.
Okay, and we have a question from Ben. Ben asks, do you have any recommendation for using pass-through queries in an environment where you use both a development server and a production server? The server name seems to be hard-coded in the query, which makes it difficult to move from development to prod.
Okay, the server name shouldn't be hard-coded inside the SQL. It should be held inside the connection string property. If there is something inside the SQL, then my recommendation would be you move it out of the SQL and you move it directly into the connection property. And what you need to do then in moving, it's a very common problem this, in moving between your test and your production environments. And ideally, there's a couple of ways you can manage it. One way of managing it is to manage it via a system DSN, because a system DSN can then just be very easily switched. Although you do then have to use, if you're on the same machine, you have to be a little bit careful because you have to maybe be deleting and recreating the DSNs as you're doing your development work. The other way of doing it is, normally, as I said, the connection string information holds the server for a pass-through query. Wouldn't be actually involved in the SQL. And what you do need to do, though, is you then need to run through the query desk collection, which contains the pass-through queries, and repoint the connection property. But on my site, I've got some stuff for relinking tables, and if you search on the internet, you'll find there's lots of stuff for relinking tables and relinking queries. Pass-through queries, you should find a lot of examples for that. But you might actually like that. I'd be quite interested in seeing the syntax you've got actually for that. If you're having a problem with how it's embedded, because it shouldn't really be embedded as part of the SQL.
Okay, and one final question is from Salvatore, and he asks, can you successfully run a 32-bit Access 2003 application on Access 2010 in a 64-bit machine? Okay,
good question. That's a very good question. Okay, can you run a 32-bit Access application in a 64-bit machine? There's actually another question associated with that, which might be of interest as well. The question you're saying relates to the actual machine being 32 or 64-bit, and you shouldn't have any problem with doing that. You shouldn't have any problem with doing that, and I mean, we don't have any problem. We deliver accdb files out to 32-bit and 64-bit environments, and I haven't come across any problems. The bit that you do want to watch is the differences between 32-bit version Access 2010 and 64-bit version Access 2010, because there are other considerations. The accdb files, if you use those, they have to be rebuilt, and if you build it in 32, it will only run in 32-bit VBA. If you build it in 64-bit VBA, it only runs in the 64-bit VBA. If it's an accdb file. If it's a standard accdb file, then generally you have to watch for things like the Windows API calls have to be handled. You have to watch for things like not using controls like the tree view control, which isn't supported in 64-bit VBA. So in summary, a machine, 32 64-bit machine shouldn't make any difference to you, but the version of VBA can make a difference.
Thank you very much. Oh, and looks like we have one final question that just came in, Andrew. It's from Dwayne, and Dwayne asks, can the steps that you showed us today be duplicated in SQL Azure?
Can the steps be duplicated in SQL Azure? I don't think there's. I use all these techniques in SQL Azure, so I don't think there's anything I've shown you today that's that you couldn't replicate in Azure. It's the answer to that one is yes. You can use all these techniques.
Okay, perfect. With that, folks, we'd like to say a very big thank you to Andrew for his wonderful and informative presentation.